MotoGP prototypes have been using pneumatic valve technology for quite some years now, and what it does, it helps them rev that much higher, that much safer. Now with the introduction of the CRT class 2 years ago, they have been using heavily modified road engines with regular valve springs, and that is until a couple of races ago when Hector Barbera got pneumatic valve springs. Now he only has one engine at the moment, but it's already helping them that little bit with top speed. So to find out exactly how the technology works, what it does, and what the benefits are, we're going to catch up with his crew chief, Giacomo Guidotti.
The street engine is designed for a certain limit of RPM, and when you increase the power of the engine and the revolution, you're going to be in a very critical area where the valve spring doesn't follow the speed of the valves due to the camshaft movement, and it can cause the broken of the spring. So we study a system which is pretty much usual now to have in the racing motorbikes and car, and we try to make our new development in this direction. We make a new casting with a new different machining to use the pneumatic valves in our Kawasaki engine. The air, instead of the metallic springs, will decide for the lift and the rebound of the valves. We generate the pressure by a special compressor, which charge our bottle about 200 bars. Then we load the pressure we need for the engine when it runs by this plug and into this bottle by a regulator, where we will charge about 170 bars. Then regulators give and keep the pressure in the head compression by special passage, and it stay around 10 bars. And we work, the engine work with 10 bars pressure in the head. And for every hour of working, we have a leak of air, and the pressure we need to keep everything with the right power is filled from this bottle. Of course, everything is linked with our wiring, and then we have a few sensors to let us know how is the situation in the engine. So by the dashboard, we can see how is the pressure on static and also in dynamics. So below a certain percentage of pressure, we need to refill the bottle again. And it happens basically 3 times per day. Well, this engine which is from a street bike engine, which is already one high-level performance. When you lift about 1000 RPM, you can increase about 5%, 8% in horsepower. And pneumatic valves can run the engine over 20,000 RPM, and for us is too big range. We are actually using 15,500. The engine is stronger, the power is more, RPM as well, so we need to take care about our fuel mapping. So that's why we need to an extra work in mapping as soon as we decide to use this spec engine. The job we tried to do was keep the same character, so some bottom and mid-range performance, and increase it from mid-range to the top. So basically the extra potential you can see in top end, full straight, full gas. So you should use longer gearing and have more speed.